Hello and welcome to our presentation. This is covering an autonomous gardening robot named the Garden Guardian, and those who made it were Josh, Naib, Christian, myself, Esol, and Emilio. The Garden Guardian is an autonomous watering robot. The point of it is to make it easier to water plants without the need for human influence. It'll know when a plant needs to be watered based on readings it receives from a moisture sensor placed inside a plant pot. Based on what those readings are, will determine whether it begins to move forward, and it'll keep itself orientated while moving forward based on readings it receives from a gyroscope. Okay, so we have our Arduino flow diagram. At the start, we have our setup and initialization of components and variables. And from there, basically, the robot will start to gather information from a moisture sensor that's being communicated with serial communication with an ESP8266. What the moisture sensors are measuring for is to see if moisture levels drop below 800. If they don't drop below 800, then the robot will remain stationary. If they do drop below 800, then it'll begin to advance forward and start measuring angular data with a gyroscope using its initial orientation as reference. If it starts to measure angular data that's a positive value, then it'll modify the left motor speed using a high kp value. If it measures a negative angular value, then it'll modify the right motor speed using a high kp value. This is so that the robot will continue traveling in its initial direction of orientation. From there, it'll keep traveling forward until the ultrasonic sensor detects an object that is within 20 centimeters of it. If it doesn't detect that any objects within 20 centimeters of it, then it'll continue this loop, continue traveling forward, and correcting its direction with the angular data, modifying the left motor if it's a positive angular value, and modifying the right motor if it's a negative angular value. If we do eventually come across an object that is within 20 centimeters of it, then the robot will stop advancing forward. Okay, so here we have our flowcharts for our ESP8266s for both the access point code and the client code. To start with the access point, we establish an SSS ID and password, and then we create a server so that it can listen to port 80. Afterwards, Wi-Fi access is set up and a server is turned on. From here, it can listen to requests from the client. Once it does receive a request from the client, then it'll start to read values from the moisture sensor and send those values, moisture levels, over to the ESP8266 client. And then it'll just continually do that. Okay, for our ESP8266 client code, we start by attempting to connect to the access point. If we can initially connect, it continues to loop and attempt to connect to the access point until it eventually does. After we do receive connection, if we were to lose that connection at any point in time, the last measured moisture level from the access point would be sent to the client code. If we don't lose connection, then the client would connect to the access point's IP address and initialize HTTP transmission. From there, it'll send an HTTP GET request, and if data is received, then it receives moisture values being measured from the moisture sensor connected to the access point. That's then sent over to the client, that's sent to the Mega Arduino. From there, the HTTP transmission would end. If we didn't receive the moisture level data, then the HTTP transmission would end anyways. From there, we loop it once again, connecting to the access point's IP address, initializing an HTTP transmission, sending the GET help request, the GET HTTP GET request. If data is received, we get our moisture levels. Then the transmission ends. If we don't, it'll end anyways. And if at any point in time during this loop we were to lose connection, then once again, the last measured moisture level measured from the access point would be sent to the client. Okay, so here you can see our prototype. You can see us finishing up construction on it and installing the final components we need before running the code and seeing how the robot works. Okay, so here you can see us physically testing the code of the robot. Once the moisture sensor is inside the water, you can see that it won't move forward anymore. That's because moisture levels are above 800. Once the moisture sensor is taken out of the water, moisture levels are now below 800, so it'll move forward. We'll physically mess up its direction sometimes to see if it'll correct itself. If it's aimed to the left, it reads negative angular data, so it'll turn off the right motor until it's facing back forward and reads zero angular data again. If it's aimed to the right, it'll read positive angular data, and it'll turn off the left motor until it's facing forward and reading zero angular data again. As it moves forward, we'll also physically block it to see if it'll stop when it reads something within 20 centimeters of it. If it does, it does stop, and then once we remove our hands, then it'll start to go forward again. In conclusion, we were able to create a robot with a functioning navigation system. Its initial movement would be determined based on readings measured by a remote moisture sensor. Upon moving forward, it was able to fix its angle of orientation if it were to steer off course, and was able to prevent crashing by stopping within a certain range of objects. In the future, we hope to mount a faucet and a watertight container on the robot to disperse water to plants. We also hope to improve the navigation system of the robot so that it could locate plants even if their locations were to vary.